This video is about the overhead drive. A lot of what I'm going to talk about in this video is on the Ornamental Turning Book of Knowledge website, and a link to that site is in the comments. There are two ways to drive a cutter on the cutting frame. One is to mount a motor right here behind it, and that works fine, but there's another way to do it, and that's using the overhead drive like I have here. I chose to use the overhead drive as I can drive multiple cutting frames and multiple drilling frames using the same motor. And that's a cost savings over time. If you only have one, it's actually more expensive to do this. Not tremendously more, but it is a bit more expensive. And the other thing that I like is that by having this motor way over here versus where I'm working over here, that gets that noise away from me, and that's really nice, and it gets that big piece of bulk out of the way. Obviously I don't have a smaller motor here, but it would get that bulk out of the way from where I'm trying to do work. And sometimes seeing inside where you're doing things is difficult enough just with this much bulk, much less if you added a motor there. So that's one thing nice. And the other is that I can reverse the direction very easily. All I have to do is swap the cables like this, and it would go the opposite direction. I don't have to get into any complicated electronics or anything. This design follows the one outlined in the AAW article by John McGill, and I have a link to that below. It frankly is not that beautiful, and that's okay with me because I don't really care that my tools look beautiful. What I care about is what I make looks beautiful, and this does a great job at that. So let's start on the right. We have this electric motor here, and that came off an old Delta MIDI lathe that I had. It's single speed, so that's why you see the pulley up here with multiple speed settings. You know, there is a replacement for the Delta MIDI lathe, which is variable speed, and Penn State sells that. It's a good one, and many people use that for this same function. There is also one from Shoreline, and it works as well. And I've got both of those in links at on the Ornamental Turning Book of Knowledge page. I will strongly advise against using a router for this function. One of the problems with a router is that it runs just way too fast. And if you try using a router speed control, I suppose it would work, but you can find old motors like this probably cheaper than buying an old router. So you'll see that I have a fixed speed motor, and so I have a pulley which allows for different speeds. The one that it's on the bottom is the fastest speed, and that's one that I use the most, but occasionally I'll have to move it to a slower speed. And you do that because the wood that you're cutting with the cutting head down here sometimes can get burned. Osage orange is one that's very cautious you have to be with making sure that it doesn't get burned. So the pulley that I have there is made out of aluminum. You certainly could make one out of any hardwood. This crane arm that it's attached to has notches in it, and those notches basically leave it where I want it to be. And it allows me though to move it backwards and forwards depending on what my desire is. Right now this is a nice line here that I have for my cables, which are my drive cables. But if I were having them, you know, lean out at a strong angle like this rather than as a vertical, I may want to move this in so that I don't have such an angle that would cause problems and may even cause it to jump off the pulleys here. Okay. The guide pulleys up here, you can just see the bottoms of them. They're made out of aluminum, but certainly you could make those out of wood or even plastic if you wanted to. The drive belting that I use is polyurethane. Some turners use a textured version, but you know, I got to tell you, I haven't gotten good enough yet to know that there is big value for that. It started out orange, and you know, this is what it looks like when it's new. I'm going to show it to you in a little bit better in a minute, but it does start out orange and kind of gets brown like this over time, but it still works, and you know, that's really the key point. This cable belting, you buy it by the foot, and I get mine from McMaster-Carr. There's a link to that in the Ornamental Turning Book of Knowledge, and I'm going to show you how we weld it together now. To fuse the ends of the cable, I use a soldering iron and a cable welding jig that Ron Hagedorn, aka SureWeld, posted on the OTI web forum. It's easy to make, and a link to the directions are in the comments. I've had a few questions on how to use it, so I've added that here. That smoke is coming from the soldering iron from where I've used it before. So the first thing we do is put this into the vise. That way we got both hands free. Heat up the soldering iron, and I find that the flat tip works the best. So we secure both ends in the jig so that when they touch, there's still a bit of pressure on them like that. Okay? What we have to do then is hold it open, get both sides really hot and melty, and then let it close up, and it just takes a few minutes to fuse it. And that's good. It's not exactly perfect, but it'll do. So you need to trim this squeeze out away from the belt, and I just use this little bitty Delta belt sander. Works fine. So give me a second and I'll take care of that. It's lightly touched. That's the key point. And that's perfect. Remember, it doesn't have to be beautiful, it just has to work, it has to hold. Okay, if you're interested in more information on this topic, check out the web pages on the links below. And thank you for watching. I hope this has been useful for you.